let's learn a brand new programming language. Let's learn Python. It is one of the most popular languages in the world today, probably the most popular language in the world to learn, and it's one that many schools teach first. A lot of the UCs especially, they teach Python first because they have quarter systems and they can teach 2 languages in a year. It's easier for them, harder for us. But I want to teach it to you now. It's very fun. I hope that you will see that it's very similar to Scratch in a lot of ways. And so to get Python, it's not like it's not a website you go to. It's a programming language that you install on your computer and you run programs in Python. So please go to python.org/downloads. You can also just search for like Python download, but you gotta install it. You can install it on the computers that you're on right now, the big ones. It's totally fine. Just like click Python download Python, click the link. And you want to download this one, Python 3.13.2 is apparently the latest version. And so I've removed it on my computer so that I could add the latest version just like you guys. So here you want to run the installer once it downloads and just say install now. It should be fine. So yeah, please do that so that you can follow along. And then once it's installed, it'll be faster for you since you have faster computers sitting in front of you. What you want to open, you want to search your start menu, not for Python, surprisingly. You want to search your start menu for, it's a program called idle, all caps, idle. That's going to be a way to run Python programs and make new files. It's more user-friendly, all right? So you want to open up the program called idle that gets installed. You can search your start menu for it, okay? That's where we're going. There are websites where you can run Python programs, but eventually they will not work for everything you need in this class. You're going to have to install it one way or another on your home computer for sure to do the assignments. So it's trying its hardest, but yeah, you want to open up idle after it's finished. IDLE. I think it's done. Cool. Setup was successful. So you do not want to search your start menu for Python. You see how it says a bunch of things that got installed. But you don't want to click Python. That's not what you want. You want idle. IDLE. All right. If you click Python, it won't be right. It'll just be like a terminal screen. It won't be exactly what we need here. So yeah, I hope that made enough sense, did it? It's trying to run. There it goes. So once you hit idle, this is what it looks like. It has a bunch of places. You can start typing here. But I haven't told you what to type. So does that make enough sense where we need to be? Idle. All right, so while you're working on getting that installed, hopefully it's not too bad. We want to open up idle, remember. What you get when you open up this program called idle is the Python REPL, R-E-P-L, it's an acronym. So what it stands for, the REPL, it stands for Read, Evaluate, Print, Loop. Read, Evaluate, Print, Loop. All right, so you can start typing stuff. You can type individual lines of Python code, and it'll run it for you, like 2 plus 2. You hit enter, and it reads your 2 plus 2. It evaluates it to 4. It prints out the answer, and then it loops back around so you can do more things. Does that kind of make sense? So yeah, try to get all that installed, and then while you're working on that, I think we still need to do attendance, right? So please, also let's do that. Just wanted to get all that downloaded first. So yeah, please also do attendance when you can. But yeah, remember that we're going, downloading Python, opening up idle. Not Python, surprisingly. So yeah, what this REPL is just a place where you can type little lines of Python code. So Python is a text-based language. It's not like you're dragging blocks around anymore. You type text and it becomes code, all right? It's like if you can do 2 plus 2, you can do 2 times 3, the star means times. You hit enter, it reads your stuff, evaluates it, and prints out the answer. That's what it does. That's what the REPL does. You don't write full programs in here, but you do like quick math or something. So like 2 plus 2 is technically valid Python code. 2 times 3 is technically valid Python code. Does that kind of make sense? That's what the REPL does. It reads your stuff, reads, evaluates, prints out the answer, and loops back around and keeps on doing that until you're done. Okay? Any questions about that so far? I think you very complicated things. Be like, what is 2 to the power of operators, 2 stars? What is 2 to the 100th power? And it's like, it's that. Which is very nice. It does it accurately. Some languages don't. So yeah, let's all understand that. So you can type individual lines of Python code. It will run that one line for you and go from there. All right, so it's no longer blocks, it's lines. So yeah, I think now it's time to just like give you an overview. So what in the world is Python? It is a programming language, just like Scratch was a programming language, but it's not at all graphical. Everything is text-based now. It's just like things that you type on a line that turn into your Python programs. All right, it's not graphical at all. It is still a programming language, though. So what does that mean for us then? Like we know a bunch of stuff in Scratch. We know like we've got like if then else blocks, right? If then else. We got all those blocks in Scratch, and like you add stuff into here or here depending on what you want to have happen. Like you did these things, right? One thing, and you like shoved it there. How do we do that in Python now? We're gonna have to figure this out. So it's like do thing one, then thing two. It's gonna turn into lines of text, all right? Just lines of text. Like these two things, these two ideas together, they'll be like line one, line two. You just put two lines right after the other to do the first thing and then the second. That's what it's gonna look like in Python. And then like how do you do an if then else? How do you like make it part of the if or make your lines part of the if, like make it part of the else? You're going to indent your lines. That's how you're going to end up doing it, all right? That's what you want. So just like in Scratch, yeah, if you want things to happen sequentially, you put them right after each other, two lines of code, and then you can indent stuff if you want it to be part of the body of the if or the body of the else. We'll get to that, all right? So yeah, every valid line of Python means something, and it will do your 2 + 2 or 2 × 3, whatever you want for you, including other things. But I do have to stress the word valid here, because Scratch was very nice to us. It let us just drag out blocks, and like the program was correct, because you can't have a blurry or like broken block or anything. That's impossible. Like all the things that you can do in Scratch, like you drag out and it does it for you. So you can't speak Scratch wrong. Right? There's no like make a garbled block or anything that doesn't exist in Scratch. You can, of course, make typos in text though. So there are Python lines that are not valid, that Python will not understand, that it will yell at you about. All right, so you can speak it wrong now, and Python will complain if and like draw things in red, try to give you hints as to what went wrong. But there are errors, right? So if I say blah and hit enter, it's like I don't know what you're talking about. What is blah? It's like that's something you couldn't have done in Scratch, right? You're kind of forced to do everything right in Scratch because like you had to have the things first to drag them out. You can just start typing stuff in Python. Okay, I hope that makes sense. Any questions about that so far? Did we all get to the REPL, into idle? All right. So yeah, let's just do some simple stuff. I think. What do I want to do first? Yeah, let's work with the REPL a little bit more. We'll talk about the little simple operations that we can do. These are all technically pieces of Python code. So you can do, like I showed, you can do star for multiplication. Like what's, I don't know, 7 × 8. You just hit enter and it does it for you, 56. Like stars for multiplication, slashes for division. What is, I don't know, 42 divided by 2? It's like, all right, that's 21, cool. That's slash for division. The % sign, this is why I showed you the % sign when we were doing our base conversion. The % sign means remainder in Python. So that's a normal operator that exists in languages, and so that's why I taught that to you when I was teaching it. So it's called the modulus or modulo operator. Modulo, and that gives you the remainder, remember. So like if you say something around a parenthesis, or not a parenthesis, but what is this again? % sign. X % sign y, or x modulo y, x mod y for short, gives you back, remember, the remainder. That's how I told you it on paper. It's going to work in Python this way too. Remainder after dividing x by y. So this, the % sign kind of looks like a slash, but it's some extra stuff, right? So it's the remainder calculation. So hopefully you remember that. So like what's 42 modulo 2? It's going to do the division and then try to give back the remainder. 2 goes in perfectly, goes in 21 times perfectly. There's nothing left over, so the remainder is 0. But like 43 modulo 2, it's odd, so it goes in 21 times with remainder 1, with one thing left over. Is that coming back to us? Questions about that operator? That's the thing in Python. They'll do it for us. That's pretty cool. And then it's double star for to the power of. It's not the caret operator like maybe exists in your calculator. It's double star. Caret does something completely different. All right, so it's like 2 to the third power. And like you don't have to have spacing like I was doing here. You'd be like 2 to the third power without any spaces. It'll get it. It's fine with that. Yeah, those are like simple operations, and you can of course chain them. Listen, 2 times 3 plus 4. Like it knows order of operations and everything. So you can use Python like a calculator if you want to. That's what I usually use the REPL for. But eventually you're going to make a file that has a bunch of lines of code to run in order. That's where we're going. Okay? But we got to start somewhere. Are we good so far? All right. So next I want to talk about types. This is something I just glanced over in Scratch. This is going to be very important for Python now. So there are a bunch of different things that you have in Python, and let's see, how do I want to say this? There's a bunch of different kinds of things that you can make in Python results, and the type of those results matters. It gives you like clues about what you can do to things. So there's a bunch of different types, and let's start with int. So int is the type of whole numbers. All right, so I kind of want you to think of types as little clouds, like the int type. Things that are of the int type in Python are whole numbers, like 1, 0, 42, negative numbers too, but the whole negative numbers. Those are integers, and Python knows. It knows the types of things. You can say type, and then you put something between parentheses and hit enter. Python will give back to you, it'll print out for you the type of something. It's like if I ask for, hey Python, what's the type of 42? It's like, oh yeah, that's an int. It knows. Okay, does that kind of make sense? That's important. What's the type of 42? What's the type of -7? Still an int. They're whole numbers. It knows that. If you want to work with decimal numbers, numbers with decimal places, there's a different type for them. It's called float. All right, so you can do different things with decimal places now. So the float cloud looks like this. It's a little bit bigger. It's got the end cloud in it, kind of. So what are things that are floats? You have like, I don't know, 3.14. That's a float. Negative 23.145. It can do scientific notation as well. Technically, every whole number is still a float, but you can express that as like 20.0 or something. Just make it clear. Those are floats, right? Not the same as it. So, like, what is the type of 3.14 Python? It knows that there's something different. All right, so that's going to be very important soon. All right, so that's the type, a different kind of type for a different kind of number. And then the last one I want to show you right now is called str. It's short for string. All right, str stands for string, and it's just a bunch of characters. It's just a bunch of text, things that you might want to print later, for example. So the things that are str can be things with double quotes or single quotes. It's like double quotes, hello. That's a str. That's a string. It's a string of characters. Single quotes works just fine for Python too. It's like single quotes, hello. That's a str. So it's things that you could print, like sentences. Like what's the type Python of hi mom between quotes? It's happy. They're strs. Single quotes works just as fine. Python doesn't care about single versus double. Those are both strings, things that could be printed. There is something very important now to talk about. If you put 42 between quotes, it is not a number. Does that make sense? It's not a number. What's the type of 42 between quotes? It's still a str. And that tells you that math stuff is not going to work for it anymore, because like the types of these values kind of matter when you're performing operations. Like 2 plus 2, those are numbers, those are integers, right? Those are int type things. So it will produce another int type thing. If you add strs, it actually works. Plus on strings actually does something. It just adds the strings together. It's like hello plus hi computes the new str hello hi. Does that kind of make sense? It's going to put the characters right next to each other. That's completely different than like number stuff. So like what's 42 the str plus 55 the str? It's still the string 4255. It's just characters in order. It has nothing to do with math. Does that make sense to us? Very, very different. It's a different type. Okay. You can also multiply strings. It's by a number. You'd be like, what is hello times 5? That makes sense in Python. But you see how the types are very important here. Because it's a str times an int, Python understands that, all right, I'm going to make a string for you again. I'm going to make some characters. I'm going to duplicate that string a bunch of times. That's what it's doing, all right? That's completely different, right? Stir times in is completely different from int times in, where it's actually doing work, right? Like 42 times 5 versus string 42 times 5. Do you see the difference? The types matter, and Python can tell the difference. So you have to pay attention a little bit extra now. I hope that makes sense. All right, any questions about that? So here, I'll leave this open because that's like relevant. And now I have a question for you to try. All right, so please, I guess we can go to the written nice page. Why not? So please do attendance. Go to the written nice page as well. You can get together in peer instruction groups with the people sitting next to you. I'll clear this out. And what I'd like you to do is try to create the following string in Python. Hello space, hello space, hello space, hello space, all the way to the end. I want 42 hellos, please. 42 hellos. All right, but I don't want a space right there at the end. Does that make sense? 42 hellos separated by spaces, but no space at the end of the string. Do we get it? Does that make sense to us? The idea? That's what I want. So there cannot be a space right there. Don't put one right there. Do not include a space after the last hello. Here is, and you can write your answer on the written nice page, but here is some relevant ideas that you might want to use. Idea of adding strings together, idea of multiplying strings, because you're going to want to do something, right? You don't want to type hello 42 times. Copying, pasting is not the right way to go here. I hope that makes a little bit of sense, right? So there's some relevant things that you can do to strs, and I think that's what I want you to try for a while. So give that a try, and I'll come around and help if we have any questions. Were we all able to get Python? How can you make it so there's not a space at the end? You see it? As a hint, it will be a two-step process. It'll be a multi-step process. You can't do it in just one multiplication. That's my hint. Yeah, there's a few answers in there. Does anybody want some more time? Are we ready to discuss? Some more time? Yeah. We have plenty. Don't worry about it. I'll give you another minute. I'll show you my thoughts. some combination of these ideas will help us. You see it? Okay, that's obnoxiously loud. All right, let's talk about it. Let me show you my idea. Let's make it a little bit easier for me to start with. Let's not make 42 hellos between spaces. Let's do 3 hellos between spaces. All right. So the goal, our goal string for a second, let's say, is hello space, just 3 of them. All right, with no space at the end still. So do you see, first of all, where the spaces are? Boop, boop. If I want to repeat something, like it's got to be something that appears multiple times, but it's going to have to stop a little bit before the end, right? So do you see how like this stuff, all this stuff right here is repeatable? Does that make sense to us? It's just hello space a couple times, yeah? That's going to end up being our answer. If I can compute this separately, I could always just tack on a hello at the very end without a space. Does that make sense? That'll be the secret, with just an extra plus at the end of there. That's going to do it. That's the way to break it down, I think. Okay? So, to do the size 3 ones, like, all right, start with hello space, twice, for example. That'll make this string. And then take that and add to it. You can use parentheses if you want to. I don't think this is necessary, but you could. Plus another hello. See how that's going to do what you want? Is that what we got? Let's take a look. Yeah, look at us. Oh, some of us did extra pluses. I like it. Oh, this one would have a space at the end, though, that one. Ooh, a space at the start. I like that idea. Technically, I didn't say anything about that. But yeah, that's going to be what the answer looks like. Good, good, good. We got it. Very good. Nice. So yeah, for the full answer, I don't know, here's my way. There are other options, though. I will make this string 41 hellos. 41 hello spaces. And then finally, one last, the 42nd hello without a space at the end. All right, so that's how I did it. Does that make sense? Any questions about that? Yeah, it's a nice little first challenge with Python. Now I'm ready. Now I'm ready to talk about making real programs in Python. All right, let's talk about a bunch of things. We'll make variables as well. So we need to go beyond the REPL. The REPL's okay. It's just like, it's nice for like doing quick math, seeing quick answers, but this is not. This REPL is not where you write actual Python programs. All right, so let's all just remember that. This is not where you write Python programs. That would waste a lot of time. What you do instead is you say file new. Make a brand new file and you start typing lines of Python code. All right, that's what you do for real programs. You do not write them in the REPL. The REPL is ugly. It's useful for quick stuff, but not good for long things. So what you do, you make a blank file. You say file new file. So that's where we're going soon. Okay. So yeah, Python programs, what we do is we make a brand new file and we save it as something, and you put a bunch of lines of Python code there. So this is what your files are going to look like. Just a bunch of lines, Python code, one after the other, and you call it something like program, and the standard extension for Python files is .py for Python. All right, so that's what you do. And so it's just a bunch of lines of Python statements, we say. Those are just lines of Python code. And yeah, just like for Scratch, those lines, one after the other, are going to run one after the other. I think what I want to do first is let's make a Python program that prints hello world. That's like the standard example when you learn any language. You have to make your first program, your first real program, be one that prints hello world to the screen. And the way that we do that is we use what's called the print function. All right. So we're going to use the print function. Here's how you use it. You say print, and in between parentheses, you put what you want printed to the screen. And so you'll put like single quotes or double quotes if you want to print something like hello, single quotes or double quotes, and that's going to be what you do in your Python files. All right, so this is called a function. Print is a function, and we are calling that function. All right, so yeah, I'll talk about that in a second. But what we're doing is we're using the print function. The metaphor for that is we're calling it. We're like shouting out to it. Something that somebody has written before. All right, so here we go. Let's make a file, new file. Where do I want to be? Here. File, new file, and I'll save this blank file in a place where you can have it. So let me quickly figure out like what in the world is today's lecture number. So first of all, I want to save this on my desktop, in this folder, I want to make a new folder that is lecture 13, lucky number 13 today. All right, that's where I'm saving this. I'll make a lecture 13 folder. You can save yours wherever you want. Save it in the downloads folder, wherever you want. Wherever you like. I'm going to call it hello, and then it's going to tack on the .py automatically. Hello.py. And there it is. I have a blank Python file that I can start typing lines in. I only need one to do the hello world program. I just say print, and then in between parentheses, I put what I want printed. So like a string, and I'll say hello world. It's nice and color-coded. Remember to end off your string. And that's my one line. I'll save this file with Control S or like file save. And then what we can do is we can have Python run the whole file. Run every line in the file. There's just one though. And the way you do that is you go to the run menu, you say run module. It's also F5 apparently. But if you go that route, it'll take you back to the REPL and run your program in the REPL. That's what it did. So here it is. It ran our program, hello world, is what it's printing. Isn't that cool? So that's how you write real programs. You don't do it in the REPL. You make blank files and you add to those. Just a bunch of lines of Python code. Right? So there's your hello world, and it's working. Does that make a little bit of sense? It's a start. Our programs can do what we want. We're having it scream out. Shout out to us. Okay. So print, it's called a function, and we are calling that function. So print is something that the nice Python people made for us to print text to the screen, or numbers. It'll just eventually turn it into text at least. And yeah, it's called a function. Just kind of it means that like it's doing a process for you. It's doing a print to the screen process. And we're calling the functions. Like we're shouting out to it, hey print, do this thing for me, and here's what I want printed. All right. So in general, to call a function, here's what it looks like. You say the name of the function, and then in between parentheses, you put what are called arguments. Arguments that function expects, things that you have to tell it, like take these things and use those as you're computing your answer. All right. Those are called arguments. Again, with the metaphor of like you're calling out to the function, shouting out to it, you're arguing with it about these things. All right. So in general, that's how you call a function. And so like you say its name. Here's print is the name of the function. Name of the function. And then we give print one thing. We just want the one thing printed. All right. That's one argument to the print function. One argument to the print function. All right. I think I'd like to spell that out. So let me break this line. To the print function. Very small. All right. So you'll get used to me saying all that stuff, but that's the start at least. And sometimes functions, they give you a result back, and you can save that into like a variable by using the equal sign. We'll talk about that later. But yeah, to call a function, you say its name, and you put arguments, comma separate them if it takes multiple, in between parentheses. All right. So that's where we're going. And one day you're going to write a big long program. You're going to be like, what was I doing? So you want to be able to make comments, how we leave little sticky notes for yourself, just like we were doing in Scratch. And so comments in Python look like this. A single line comment has a number sign that starts it off. You say number sign, they start typing. That's just a sticky note for you. Just until the end of the line after that. That is a single line comment. But sometimes you want to type a bunch of stuff. And so you use triple quotes for that. So here, let me show that to you. So even though I know we understand this file, let's use some comments. So the number sign starts us off, and then everything after that is not Python code. It's just a sticky note for us. All right. So this is a comment. It's not Python code. It just glosses right over it as it's running the file. Everything after the number sign is a comment, and that means you can put comments on the same line, like print hello world. It's like you can comment right after it. That's fine. It's like, all right, what does this line do? It prints hello world, in case you forgot. That's kind of nice. You can mark up every line. Sometimes you want to type a bunch of stuff, and so multi-line comments are 3 quotes. Could be either 3 single quotes or 3 double quotes, but you gotta be consistent. So you start off with 3 triple quotes, like this is, and you can keep typing. This is a multi-line, space or space, put it wherever you want, comment. And then when you're done, you just like do another 3 triple quotes to end it off. So really what it is just like a big long string essentially, and Python just glosses over it again as you're running the program. So if I run this again, it's still just hello world. The rest is just sticky notes for us, reminders for the programmers. Okay, so those are comments. Does that make sense? It's text form. Everything's in text form. All right, let's next talk about making variables, because we want to do like cool things eventually, right? We're going to need to store some values for later to make computation easier. So yeah, you can give variables and put whatever you like and then make little boxes in memory. Okay, so yeah, variable names though, there's a naming convention that's a little bit different to Scratch. You can have spaces in your variable names in Scratch, and I took care to not do that with any of my variable names to get you ready for Python, because that's not allowed in Python. All right, so variable names, the rules for variable names in Python, you can't have spaces or special characters. Your variable names have to start with an underscore or an alphabetic character. And then after that, you can use those some more, and you can also start typing digits. So you cannot start a variable name with a digit, is the moral of that story as well. So here are some valid variable names, like x is a valid variable name, underscore underscore x underscore underscore, valid variable name in Python, underscore blah 42, valid variable name, but not 42 blah, cannot start with a digit, has to start with one of these guys, and then you can start using digits. All right, so those are your valid names. And yeah, the way that you create a variable and also give it a value or update a value is with what's called an assignment statement. It's a statement with an equals sign, which I think is unfortunate, but you kind of read it like an arrow. I want you to think of it like an arrow from right to left. Okay, so here's what you do. You say variable name, and then you put an equals sign, and then you give what you want to go into that variable. So it could be something that produces a value, like it doesn't have to be like 42 immediately. It could be like 2 plus 2. Python will do the work with whatever you put on the right-hand side of that assignment statement, that equals sign, and then shove it into that variable. Okay, that's what's going to happen. And so, for example, you can say a line like this, x equals 42. That will create a variable if it doesn't already exist, and put a value in it. X equals 42 will do just this. Does that make sense? So just like in Scratch, but we have to use text to represent these ideas. All right, that's how we make a variable. And then you can use it later. That's the whole point of having a variable. You can say print x now. Print whatever's in it. All right, so let me show that to you. I'll make a new file. New file. We'll save it in the same place. I'll call it vars.py. All right, so I'll make a new variable. I'll make an x variable. I'll say x equals 42, and now x holds 42, and I can prove that to myself by saying print x. It'll go and print out whatever's in that box. So I run this file. Prints 42. Does that kind of make sense? Are we following it? 2 lines of code, one after the other, is going to run in order from top to bottom. We're good with that still? It's interesting. It's new. New but similar at the same time, right? Here's a weird one. X equals x plus 1. Think in your minds, what will this do? This is valid Python code. What do you think it's going to do? Can you see it? So it always does the right-hand side first, and that's why it's not ambiguous or anything. So always think about it like it's doing this thing first and then shoving the answer into here once it has it. So the right-hand side, RHS, right-hand side, gets executed first. I hope that makes sense. All right, and so that means what it's going to do is all right, what's x plus 1? It's going to compute that first. Well, that's 43, okay. And it's going to shove 43 then into the variable called x. It will update it. That's what it will do. Does that make sense? It's a little weird, but it works. X equals x plus 1. Print x now. So this program is going to print first 42 and then 43 because we changed it. Any questions about that? Is that still making a little bit of sense? It's fun, I think. All right, so now we have variables. We can do fancy math now and like keep everything in check in our minds. So we can name them things with words rather than just like putting a bunch of numbers everywhere. Next, let's make a program that can be different every time we run it because it can get stuff from the user. The user can control the program with input. Let's do that. So in Python, to get input from the user, one way at least, is with a function called input. So you call the function, and it gives you back whatever the user typed to you. All right. So you call the input function, and it takes one argument, just like print does. It takes the thing that you want to ask the user right as they're typing, like the little prompt that you want to show to the user as they're typing, just like the ask block was doing in Scratch. So input, and you can give something to type out. It can be single quotes or double quotes, like input, enter your name. Something like that. And so it'll be different if you run the program versus if I run the program, because our names are different. Enter your name, colon, and then like it's going to print this out and keep it on the same line as the user's typing. So I like to give it a little space right after like a colon or something. Like give it a little space so they got room to type. It looks cuter that way. And so like that's what you do. You give it what you want, and it'll show that to the user as they're typing. And then input, like it does the work, it's the step from the user, and it will give back to you something. So this is different from print. Print just goes off and prints something, but input will give back to you, just kind of like, oops, kind of like this example. It will give back to you the value that the user typed as a str. Right? It gives you back the result that is the user's response. And so you should like use it. You should save it. Save it away into a variable like resp, something like that. So what this line will do is it'll run the right-hand side, like input, enter your name. It'll show like enter your name. We can type, hit enter, and it will take whatever you got, and we're going to put the answer that it gives back, that it results in, into a variable. Call it resp or something. And so like after I run the program, it should hold the string Lawton. After you run the program, it'll hold it with your name. Okay, so that's what's going to happen. And remember, though, that always, input gives you back the characters that the user typed, even if you ask the user to type their favorite number. It'll give you back it as a str. Remember, that's very different. That is very, very different from the int 42. Str 42 versus int 42, completely different things. So there's a way to convert between types if you want to do math, but everything you're getting from input is always a str. So you better convert. There's a way to convert. All right. So we'll talk about that after this one. It's like, all right, ask the user their name. We can say hello, their name. Let's do that. Make a new file. New file. And I'll call it gettinginput.py. So here, let's make it so you can see stuff. All right. So I want to say something like this. All right, input, like enter your name, colon space, and here I'll use single quotes just for fun. I'm used to using double quotes for my strings and from other languages, but Python's fine with single quotes. And I'll take the answer that it gives back and shove it into a variable called resp, right? And then we can say, like, we can tell the user, like, hello, like print. We can build up a string saying hi, comma, space, your name or something. Here's how you can do that. Like hi, comma, space, plus whatever was in the resp variable. Does that make sense? It would add them together, create the bigger string. You can also add like an exclamation point at the end of that. Do you kind of see what it's going to compute? It's going to add these characters in the middle of whatever the resp string held. That was whatever we got from the user. That's kind of neat. All right, so if I run that, watch what happens. It's like enter your name, and that's what it does. It leaves you on that line waiting to type. And that's the reason I gave this space right here, so that like, there's some space after the colon. So I like that, right? Now you can start typing over here. It's not like immediately touching the colon or something. Like Lawton, and then you hit enter, and it gets your thing. It plugged it into the variable, and it worked. And this program's different every time you run if you type new things. Like, let's pretend my cat's playing this game. It's like hello Alonzo this time. Right? And so it's computing this value based on whatever was in that variable, which is very, very useful. Any questions about that? It's a different program every time we run it if we type different things. I like that. All right, what else? Do remember, though, that everything you get back from input is always a string. It's always a str. Let me prove that to you. So here, if I say, wrong program, like right after we get it, let's print the type of resp. No matter what we type, if I run it, Lawton, it's always a str. It's always a str. Even if I say that my name is 42, still thinks it's a str. So I can't do math on it yet. Does that make sense to us? That's very important. That's something that Scratch kind of like swept under the rug for us. It like noticed if we typed integers and made it an int. But Python, you have to explicitly say what we want. All right. So yeah, let's think about this. Let's play this game. Let's play with fire. All right. Let's ask the user enter your favorite number. And remember that what we're getting is a str, and I'll call that num this time. All right. And so whatever I got from the user, the type of it, even if it was their favorite number, it's still going to be a str. Watch. I say my name's Lawton, my favorite number is 42. That number, the type of num, printing it out, is a str. All right? And so what happened is that's what it holds right now. That's what that num variable holds. is the stir 42. You cannot do math on that yet. Does that make sense? It's like if I tried to, like, all right, I want to print your favorite number times 2, print num times 2. It's not going to do the right thing. It won't be an error because you can multiply strings by stuff. But 42 the stir times 2 is 4242. Just a bunch of characters twice. Do we see the problem there? So what we want then is to turn our num variable into an int. Convert those types so that we can do math on it. That's what we really want. And so here's how you do that. If you have a stir, you can convert it to a numbery type by calling that type like a function on the thing. So if you say int, I want an int out of what? Out of that rest variable. I want a float out of the rest variable, or the num variable, really. That's what we'll be doing. Okay. Does that make sense? So you just call the type you want to make out of your thing as a function. That's perfect. That'll do exactly what we want at that point. So now I can say int num. That will convert and give back the integer version of that number variable. And that will, I can save as something else, like num as int. Something like that. All right? This line right here is very important. Num is only a stir. Num by itself is only a stir. We must convert it to a normal int so that we can do math on it. And that's what that line is going to do. It's going to make a brand new variable. This will do the conversion. It will give back the number 42, the int 42, and we can save that safely away into a variable. Right? And then I can say print num as int times 2, and the math will work this time. See the difference? So here's this. So if I rerun this program, there it goes. That's my name, 42. This time it actually did it right. So num as int became the number 42, and I multiplied that by 2 to get 84. Do you see that? It's going to do math once you convert it. All right. You can also convert it to, if you got a decimal number from these, you say float, because that's the name of the type that holds those things with decimals. All right. Questions about that? We good? A little bit more complicated, but useful. Very useful stuff still. All right. What else? What else? Remember that functions, they take a bunch of arguments, and you can separate those arguments with commas. Print, like we've been given it one thing to print. Input takes the one thing, the prompt, one argument. But actually you could give print multiple arguments, and it will print out those things that you give it with spaces in between. Right? So if you say print arg1, comma arg2, comma arg3, it will print those three things, just one after the other with spaces in between them. Right? So that's what one thing that you can do. So technically, I can kind of change this call right here to this print. If you want to say hi, comma, space, somebody's name, you can do it a little bit differently and get most of the effect still. You can be like print hi, comma, resp, comma, exclamation point. So it's going to print hi, comma, then a space, then the resp variable's value, then a space, then the exclamation point. All right. So it's not perfect because there's a space before the exclamation point now. So there it was. There's the new way. So it just like adds the space for you. It's like print out a bunch of things with spaces in between. That's kind of useful sometimes. It's useful, I guess, with especially with the French language, because in French you put your exclamation point with a space like that, but not in English at least. So if you want to be perfect, you do have to do like, let's add characters together if you need some accuracy there. But this is another option. You can give multiple things to print. If you've just got a bunch of things, you just want to see one after the other. Okay. Oh, excuse me. I think, yeah, that's just a quick idea. Now I'm ready to talk about more functions, even cooler functions that people have made for us. So we got input, we got print. Those are baked into the language. Very useful stuff. But there are other things that are part of what are called libraries. Right, so I'm talking about the math library. There's a bunch of math functions in a place called the math library in Python. And a library is, like the metaphor is, you're going somewhere, you're checking out a book with a bunch of pre-written code for you, a bunch of pre-written text, all right? So every library, there's a bunch of libraries in Python, and what's in every library is just a bunch of code that's been made for you so that you don't have to reinvent the wheel. So a library just means it's a bunch of pre-written code that you can use inside your programs. All right? And so the math library is one of those things. And like there's a link to the math library and what lives inside of it, but you can always just search Google. It'll be the first thing you say, Python math. Hit enter. That's the name of the library, and then the very first thing, like that is the documentation page for the math library in Python. And if you scroll down, you see a bunch of things, a bunch of functions that live in this library, things that are implemented for you. So you get normal mathy stuff, right? You got your like sine, cosine, tangent, all that fun stuff. You got some constants, like pi is saved there, like variables within the library exist, e, all those fun things, and a bunch of others as well. So yeah, useful stuff. There's also a very important one that you like to use a lot is the square root function. So this will take the square root of a number, give you back it, or take a number, give you back the square root of that number. And so you don't have to write code that does that because it's hard to write that code. It's been done for you. Okay, so that's where those things live. So you can click on it, get some more information about it, see a use of it, which is nice. So yeah, you're gonna live on these pages when I give you assignments now, right? So the library documentation, very, very important. So yeah, let's talk about it. We would like to use like square root or something. We like to use a piece of that library, and the way that we tell the Python program we want to use the library is we import the library into our program. We say import and then the name of it. So we're going to say import math. It's lowercase math. That's the name of the library. And so once you say this, usually you do all of your imports at the start of the program, but you have to do it before you use the thing at least. Once you say import math, that makes all of the math library functions available for you to use for the rest of the program. So it makes math library functions available to use. Very useful stuff, right? So there's variables defined in the library, and then there's also like functions defined, and you have to like qualify the thing that you want and say that it's part of the library. It's always, once you import a library, to get the thing that you want to use out of it, you always say the name of the library, it's library name, and then you say dot the thing in the library that you'd like to use. All right, thing inside library, because maybe there's like a competing math library that has the same stuff. That's how you can qualify and separate the things. So like if you want the pi variable from the math library, you don't just say pi now after you've imported, you say math.pi. That's what you're going to do. All right. If you want the square root function, you don't just say square root, you say math.square root, SQRT, math.sign. All right. So that's what you do. And yeah, let's have a file. Let's have an example program that uses that. So I'll make a new file, and I'm going to make this file any name. I cannot call this file math.py. All right, so this is very important. If you use a library, secretly what it's doing when you say import is it's going and looking for a file called math.py somewhere. So if you name your own file math.py, it will try to import yourself, which is not going to work out. It's going to lose access to everything. So never make a file with the same name as the library. Let's remember that. All right, that will ruin your day one day if you forget that. All right, so I'm going to make a new file, and I'm not going to call it math.py. Call it anything other than that. So save it as, I will call it mathstuff.py. How about that? Because it loses access to the library the second you say that. So that's what it's doing. Import just goes and looks for a math.py file secretly in a special place. So all right, let's use this. Let's use these guys. So all right, I want to use the math library. I'll say import math. And so now, for the rest of the program, now we're allowed to use all the math library functions. Very useful stuff. And so, I don't know, for my first trick, let's use pi. Let's use the pi variable baked into the library. It's useful. So it has more accuracy than we could maybe remember. So let's do like what's an example that uses pi? Let's do like the area of a circle. Let's calculate the area of a circle with radius, let's say, 4.5, all right? So the calculation we want to do is pi r squared, right? Pi times r. You can do times r for r squared, or you can do the star too, right? To be the power of operator to the second power. It's like that'll work. And yeah, just to make it like usable, you can have like a radius variable. Make it different every time. You can rename, give this a new value. All right, the radius is 4.5. Do some practice with those variables. Like the area now, based on the radius, is pi r squared. So it's math.pi. That's where it lives. times radius squared. And the order of operations will check out, but you can draw parentheses if you just want to remind yourself what's going to happen. But the order of operations will do the exponents first before the multiplication. That's pretty nice. And so yeah, it's just very clean. You can see like your steps very easily. It's helpful to do your math work in here. Make a Python program from now on. Like I'll print out whatever the answer was, whatever's an area. And apparently that's the answer. All right. To a lot of decimal places because the pi, like the math.pi variable, if I have it print out in the REPL, is a very accurate version of pi. That's pretty nice as a float. Okay. Questions about that? That's me using a piece of the library. You import the library and then you can start saying math dot the thing in it that you want. All right. Yeah, let's use square root. Square root takes one argument. It takes the one thing that you want the square root of. You can click on the documentation to prove that to yourself. Like square root of x returns, take that one thing, gives you back the square root of that thing. All right. So let's make a program that uses that. Or let's continue this program. Yeah, not like that. Let's add some lines so I can scroll up. There we go. So let's calculate the square root of a number that we get from the user this time. That the user types. That'll be useful. So let's ask the user, hey, user, input, enter number, colon space for the prompt, and then let's save that number as num. And remember, we want to take the square root of that number, so we better convert it, because num is going to be a stir right now. Convert it to a string, or convert it from a string to some value. The user usually, like, if you want to take the square root, it doesn't have to be just an integer that you take the square root of. You could ask for the square root of 2.5. So we don't want to convert this number to an int. We want to convert it to a float. Float of num. Convert the string to a float and call that like num as float. That will be perfect, all right? And then what I want to do is compute the square root of that number that I just converted to a float. So here, let's do the math first. So math.square root of the number as the float. That's the variable that I'm using for that. So this will produce the answer. And then I want to this as if it got replaced with the answer is essentially how that works. And so I want to print that. So it's a chain of function calls. So the very first thing that will happen is it's going to run the inside stuff. It's going to call this function, get the answer back. And if a function call gives you back an answer, it's as if it's being erased with and rewritten with the answer in there. So it's as if I said, print the answer. Print like 1.4 if it was the square root of 2 or something. And that's what's going to happen. It'll be replaced. And so immediately print whatever this gives back. That's how you can read that. So let's run that. I'll do run module. Enter number 2.0. Like it's a float, it'll work. So there's the square root of 2. If I rerun it and say, like, I don't know, 4.5, apparently the square root of 4.5 is this to some decimal places. All right, so I'm using the function from the library only after I've converted the types, though. It won't work unless you convert the types. We still happy? That's pretty cool. What else? Let's do one more example. Let's do one that just uses sign. Why not? Take the sign of something. And I do need to be careful about that when I teach it to you. By default, the sign function in this library, it takes a sine of an angle, and that angle is in radians. It's radians mode all day long for the sine function. There's some conversion functions to convert to radians or from radians. These ones up here, you can read those. But every time you call sine or cosine or tangent in the library, you have to give it radians only. Okay. So yeah, let's do that. So let's make a program that uses that. Let's add to this one. So let's say, I don't know, let's take the number that the user already gave us that we just took the square root of. Let's also do the sign of it. Why not? So in addition to printing that, let's do the sign of that number. Let's do, sign of num equals math.sign of that num as float, because it's got to be the number as a real number. That's what it needs to be called with. Pretending that it's in radians, and then we can print out the right answer in a pretty way. It'd be like the sign of, and then give the original number, because it's like that one, right? The sign of that. We can use separate arguments, because it'll space separate it. is, comma space to separate it, right? Sine of num, whatever I just shoved into that variable, whatever the library gave me back. So that kind of makes sense what I'm doing there. Get the answer, and then print it out in a pretty way with spaces in between, because everything you comma separate, it's just going to print those things out in a line with spaces in between. So if I give it, what's the sine of pi? That's 1, right? 3.14. Oops, I did it wrong. What did I do backwards? Oh no, I just spelled it wrong. So here, I said 3.14 and then it yelled at me. Oh no, so I made a mistake. And let's read this. It's a good learning exercise. So it's like on line 16, there was an error. I don't know what to do. So you can see what line you're on. In the bottom right, it's very small. So line 16 is this last line, all right? It's this last line right there. And it's saying, sine of num is not defined as you mean sum of num. And yes, it looks like I gave this variable the wrong name. See that? So it's very helpful. It's like, I don't know what you're talking about, but that's an error, right? We can have those kinds of errors in Python now. Okay, now it should work. Let's say that my favorite number is 3.14, and the sign of that is very close to 0. 0 with 2 decimal places of precision, at least. All right? So the sign of pi radians is 0, right? Yeah, so I think that's what I wanted to say. Does that make sense to us? Any questions about using the library to do stuff? Saving the answer into variables, building up answers, using the results of previous things. All right, your turn. So I'll leave this program up because it's useful. It's like showing you what you need, like import the library, use the library. I guess I've given you everything you kind of need here. Here's your question. I would like you to write a program, please, that takes 2 numbers from the user, call them a and b, for example, and I want you to compute the square root of a squared plus b squared. So you're going to make a program that does the Pythagorean theorem, all right? Gives you the size of the hypotenuse. So like if a from the user was 3 and b was 4, your program should calculate and print out 5, right? Because that's the square root of 3 squared plus 4 squared. Does that make sense? That's the program I'd like you to write now. So please give that a try. You don't have to type it in anywhere. That's fine. Just for yourselves, you can put it wherever you'd like. But here is your goal, and here is my sample code that you'll want to use a lot of. So remember to import the library, you're going to need square root, math.square root, and then to do squareds, it's this kind of thing. You see all the pieces? Input. Yeah, so give that a try. Do we have any questions before we begin? I just want you to practice. It's a good way to get it working. Try to follow the errors if you get any. I'll give you plenty of time. I'd be happy to help. Just let me know. Okay, if you want something from the user, you have to say input. So if you want 2 things, you're going to say input twice. Two separate variables. What number am I getting? If it's going to have decimal places, it's got to be a float. It can't be an int. Ints cannot hold decimal places. You don't have to submit this answer or anything. It's just for yourself to practice. Give you another couple minutes, then I'll show you my answer. You don't have to type this anyway. It's not a written nice question or anything. Just want you to try. Is anybody stuck? Can I help you? Looking away? Right. Take these pieces. They'll all fit together. I promise. Right. So yeah, I hope that was enough time to give it a good try. Did you get working for at least the 3, 4, 5 triangle? Did any questions come up that I could answer before I just show you the answer? Alright, so here let me make a new file. And what should we call this? I'll call it hypotenuse. So that's what we're solving for essentially, right? And I'm going to do very similar things to that last program. I would like to get some numbers from the user. Well, I'm going to use square root eventually, so I need to import the math library. Right? And then I need two numbers from the user, which I will call A and B. Why not? So A becomes the result of inputting into a variable. Enter A, colon space, like get the value, shove it back into a variable called A. Same with B, right? But these are just strings right now. A and B are just characters. They're not actually numbers. If these are types 3.14, we're getting 3 period 1 4. Just the characters in order. There's no meaning to them yet. All right? That's what we get back from input. And so what we want to do is, like I did in the other ones, we want to convert our input to like a float or an int. Let's do float because these might have like triangles with weird sizes. That's fine. So we'll take the float. We'll convert these strings into floats. And we can call it something else. But here's a fun thing. This idea of chaining functions is quite powerful. You can just say, all right, input's giving me back a str. Let me just like take that and make a float out of it. Can you kind of see how I'm using that? Does that make a little bit of sense to us? It's like it'll just get replaced. So you can chain the function calls. So make a float out of whatever input gives me back. Input will result in something. And like the result's going right where it was, right there. Like if I type 3, then like input enter A, like will get turned into essentially the string 3. That's what the result will be. It's just going to be placed right there as if it was replaced. And then just immediately take the float version of that, give me that answer, and then shove it into A. See how like in one line you can get the thing and then also convert it to the type you want by changing those, by chaining those function calls. It's very useful. I hope that makes sense. Please yell at me if you have any questions about that. But now I have A and B. Those are actually numbers now. I can do math stuff with them. I can do math dot, what is it? Square root. I want the square root of what? A squared plus B squared. So just like that. And then I can save that as a variable. Why not? A hypotenuse, HYP, is equal to that. And print HYP. So cleaner that way, right? You can just make a variable for the answer and kind of see what's going on. So you give it a name that sounds like normal. And that should do it. Does that make enough sense? Any questions about this? Let's watch it work, or see if I made a mistake. So if A is 3.0, B is 4.0, then yeah, perfectly 5.0. What was the other special triangle? Do we remember? Because I sure don't. It's like 3, 4, 5, and I know it's like 1, 1, root 2 or something. Was there another? I really don't remember. But yeah, there's the square root of 2. Cool. But it's going to work for anything, including with decimal places, because we converted to floats, like a triangle with a base of 2.5 and like a height of 3.5. Apparently the hypotenuse is that. Like, it's fine. It's happy because we used float rather than int. So we expected to maybe not see a whole number every time. Right? But that's how it's going to do. It's going to get the value, get the string from the user, convert it to the type we care about, shove it into a variable, same for the other one, do the math, save the answer into a aptly named variable, and then print out the final answer. Okay? Any questions about that? I think that's fun. So that's important stuff. Try to study that. And I think that's what I want to do today. There's some other things that I want to show you, like if there was time. There's no time because we have to give you a million things right now. But I encourage you after class to like make a program using what I've just shown you that does something like solves your math homework or something for you, because that really helps you learn. But I do want to, before we go, show you this called Python Tutor. It's a website. It's called pythontutor.com. You can go there. Like Google will take you there. Python Tutor, you just search for it, click on it. And what you can do on this website is you can say, I guess you click on Python, I guess. And then what you can do is you can give it a Python program down here, and it will print it out for you, all right? What you can't do, the only thing it can't do is get input, so like you have to hard code input. But like here is, let's do this program, for example, the simple one. It's like, if you don't know what's going on, like it's working, but it's not doing the right thing, you type your program into here, you have to hard code any inputs, and then you click Visualize Execution. And what happens is it takes you to this page, and you can step through your programs, like x equals 42, next. It'll start drawing the program as it's running. Isn't that cool? And like up here is the output. Sorry, it's kind of small. Then you click next, like, all right, I'm on this line, print. Oh, that's why it's printing that. On to the next one. Click next, it runs it. See how it made it 43 now? This will save your life, this website. It'll show you exactly where your code is going wrong. Like, all right, print 43, there it is, it's done. It's called Python Tutor. So step through your code to see why it's doing the wrong thing, or to learn why it's doing the right thing. Does that make sense? Very useful program. So yeah, that's that one. And yeah, I just want to give you a bunch of assignments at this point. There's a lot of things that I need to give you because we don't have time next time. So, all right, we've got 3 things. I'm going to release them all. So we need another essay, because you got one due. Talking about that one. This shouldn't be too long, because you're going to have a midterm. It's not going to be the world's longest essay. Make it easier on yourself, but it'll be due in 2 weeks. And like it'll be 500-word essay about this article. So go here. It's this article about the S25 machine. Have any of us heard of that, by the way? For computer science majors, maybe we have already. But it is a very sad story, unfortunately. So read all this. Read this this little article, mini article, and then I want you to write a response. So what I'd like you to do in your essay of just 500 words is, there's an issue, right? This is about a machine that was made in the 80s and it hurt people, right? There's a problem. It had to do with computer science, so we're reading about it, ethical issues. So talk about any false assumptions that were made by the manufacturer, right? So you can also look at the Wikipedia page for this. It's a famous issue. And just kind of tell me what you would have done differently. If you were in charge, how would you prevent this S25 disaster? Because it was a disaster, all right? So you don't have to do too much. I don't have any strict, hard requirements. Just like respond to this prompt in 500 words at least. You don't have to cite anything, but you might want to cite the article or something if you want to. But I think that's all. So that's not the world's hardest essay, I think. So please read an article about a very, very important problem that was in our field, and write a response talking about these things I'm asking you to talk about. Questions about that? So yeah, plenty of time to do it. That's your 500-word essay. Not too horrible, I hope. All right. So that's that one. And then, what do we got next? What in the world? Why is this? Did I not click it? I'm confused. Let me refresh the page, sorry. Okay, apparently that one didn't go through. All right, 2 more things. Let's do it out of order. Let's do the extra credit first. So I have an extra credit opportunity for you guys if you'd like to do it. Don't have to, it's just extra. But if you would like, you can learn JavaScript, all right? If you have not learned it already. If you have already learned JavaScript, you have to talk to me and I'll give you a different extra credit assignment. But if you don't know JavaScript, it's another language similar to Python, and it'll be worth up to this much extra credit. So what I want you to do, if you'd like, for the extra credit, is to go to this Khan Academy course and go through it. All right, so here's a bunch of sections about Python and stuff. You click on each one, like all these things, and you do them. Like you start with the first one. Sure, I'll accept the cookies. And you just like walk through, like you do the things. There's some assignments that'll walk you through. Like there's a challenge. Like you'll complete those challenges. Right? So you'll complete all these things. Why is it so small? There it goes. Please stop. There it goes. It's like you do the challenge and it tells you if you did it right or not, stuff like that. And like every time you complete something, it will leave some little marks. See how like I did something and it will put a little line. That's how I'll know you did it. All right. So what you do is like you go through it. If you want just 2.5% extra credit, half the extra credit, please go up to complete everything up to the variables section. So all the way down to and including this guy. Like you take all the things to the right. All right. If you want the full extra credit, go down and complete up to and including the interactive program section. All the way down, 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 including this one. All right. Does that make sense? That's what you'll do. And that's what you'll turn in. And just give me a screenshot or just, I guess I want a video. Give me a video as your submission where you just like scroll through and show me that all those little bars are on the right side showing that you completed everything. All right. So you have like a month to do this. I think that's when I gave the due date, or just maybe 3 weeks or something like that. So if you'd like to do it, do it. Not too horrible, but useful knowledge as well. It'll help you with your Python. Any questions about this extra credit opportunity? All right, we got 5 more minutes. Let's keep on trucking. So that's that one. And then the last thing I want to talk about is we are currently in week 8. We got a midterm, right? It's like we're in the middle of the semester. I guess there's 17 weeks of class and an 18th week of finals week, so we're about in the middle. And every time I teach a class, I like to give a mid-semester anonymous feedback form for you guys to fill out if you'd like. Of course, not required. It's going to be anonymous, so I can't trace it back to you. Say whatever you like, but I've made a little survey for us to take. If you would like to take it, I encourage you to. Say as much or as little as you'd like. Here are the kind of questions that I would ask you. Like, give me 3 things I should keep doing, stop doing, start doing. Just like give me some feedback about the class while you're still in it. It will help me like make the class better next semester. And then also if like something's going horribly wrong, you can tell me about it now. I can change it for you guys still. Does that make sense? Yeah, it'll be anonymous. So like you can say mean things if you want. That's fine. I won't be able to trace it back to you. But it will only help me make the class better for you and for my future students. So I would appreciate it if you would fill that out if you have time. All right. So yeah, I think that's what I want to say about that one. It's just a Google form. You go to it. You don't have to sign in or anything. And it's not for credit. I think that is officially everything. Are there any questions about anything I just talked about? It's a lot of things. And then don't forget about the midterm. So we're coming back on Wednesday. We're going to have a midterm. I want you to take the exam. It's going to be right here on Canvas, right? You click it on Canvas, and I want you to take it on the big computer, so not on a laptop, please. So you're going to log in on Canvas once you get to class on the big computers and take the exam there. Okay? We ready for it? Are there any questions about that before we end today? So make sure to check out the info page if you like missed the class when I was explaining it. But I think that is officially all that I want to say, at least as far as I want to record.